Hi, welcome back to Chapter 2, Atomic Structure. In this video, we are going to continue with 2.3, Electronic Configuration. The objective of this video is we have to know how to link the electron into orbital based on three rules: Aufbau principle, Hund's rule, and also Pauli principle. In this video, we are going to focus on electronic configuration. This is the terms that we always use. However, another general terms that can represent electronic configuration is electron arrangement, or in Bahasa, we always say susunan electron. Okay, so maybe you can recall back in your SPM, you always will write the susunan electron in terms of 2A2. Okay, but this electron arrangement or this electronic configuration will not be used in matrix. Okay, this is the pattern that you use during your SPM time. So here we will introduce you two types of electronic configuration. First type we call as SPDF notation. So I just roughly give you an example. Okay, 1s2, 2s2, 2p6, 3s2. Okay, so this is an example of SPDF notation. Second type of electronic configuration can be represented using the orbital diagram. So just would like to remind you, orbital diagram is not equal to shape of orbital. Okay, so how the orbital diagram looks like? So it will look like in a box. So the first box is 1s, can fill 2 electrons. Second box is 2s, can fill 2 electrons as well. The next box is 2p orbital, but as we know, we have px, py, and pz. So that's why here we have 3 boxes that represent 2p orbital. So we fill the electron singly, okay, and then after 2p is already full with electron, then we are going to fill up with the 3s orbital. Okay, so in this video we are going to check how we're going to fill in the electron into this orbital based on the 3 rules that we are going to discuss soon. Let's start with the first question. State the Aufbau principle. So according to Aufbau principle, it let us know that electron must occupy a variable orbital of lower energy level first before they fill into orbital with the higher energy. So in general, you may think that we will fill into the energy level n equal to 1, followed by n equal to 2, and then n equal to 3, and so on. Okay. However, Aufbau found that there is a pattern when we want to determine the energy of an orbital. Okay, let's look at here. So I call this one as the Renning pattern. Okay, Renning pattern. So we will list down all the possible orbital for each energy level first. For example, in n equal to 1, we have 1s. n equal to 2, we have 2s, 2p. n equal to 3, we have 3s, 3p, 3d. n equal to 4, we have 4s, 4p, 4d, 4f. And n equal to 5, we basically have 5s, 5p, 5d, 5f, 5g. Okay, while for the n equal to 6, we have 6s, 6p, 6d, 6f, 6g, and then 6h. 7, 7s, 7p, 7d, 7f, 7g, 7h, 7i. Okay. However, we will not look at the g orbital and also h orbital. So that's why in this slide, I only show most of the orbital that we are going to involve them when we writing the electronic configuration. Okay, so again, we look at the pattern 1s, 2s, 2p3s, 3p4s, 3d4p5s, 4d5p6s, and then we will fill in 4f5d6p7s, and then 5f6d7s, 7p. So when we base on this so-called running pattern, we are not follow the energy level n equal to 1 and then 2 and 3. We have to follow this pattern. Okay, based on previous slide, so we can rearrange or arrange in a proper way the orbital based on the energy. Okay, so 1s has the lowest energy, followed by 2s, 2p, 3s, 3p, and then 4s, then only 3d. Okay, after 3d is 4p, 5s, and then 4D, 5P, 6A. So means that it is not fill up all the orbital in n equal to 1, then only we fill up n equal to 2 and 3 and 4 and so on. So we have to follow the Aufbau using the running pattern. So basically, I not suggest students to memorize this arrangement because you can draw the running pattern whenever it is needed. However, for the first top here, first front here up to 3D orbital, you have to memorize because most of the question when they ask us to write the electronic configuration, they will involve up to 3D orbital or 4p orbital. Okay, so that's why 1s to 3D you must remember the arrangement. So basically it's quite easy only. Okay, so 1s, 2s, 2p, 3s, 3p, after 3p is 4s, then only 3D. Okay, so now let's check the question, tutorial question number 1b. Arrange the following orbitals in order of increasing energy. Okay, so we can refer this to arrange. So 1s is the is the lowest energy, 2s, and then followed by 2py, 3s, 3pz, and 3py. If you look at here, we use the comma sign. So means that these two orbitals, we consider they are degenerate orbitals. So what is the meaning of degenerate orbital? So we consider they have same energy. Okay, so because both of them are 3p orbital, so no matter it is 3p, 3px, 3py, or 3pz, all these three orbitals basically they have same energy. So we will not say ps is the lowest among the three, or the 3pz is the highest among the three. So three of them have similar energy. Okay, then after 3p, followed by 4s, and then followed by 3d. So again, you will see 3d, we also have 5 orbitals of 3d. So no matter which one, also can be come first. So when the energy level is, the energy is same, so we will use the symbol of comma here. Okay, and then followed by 4p, and then the highest energy in this case is 4d, xy. Okay, before we continue to question number 2, I think that better we continue with question number 3 because it is also related with the Aufbau principle. Okay, for the following pair of orbital, indicate which is lower in energy. So again, we can refer back this pattern here. Okay, when we have 2s and 3s, we can look at 2s. We can see the 2s orbital first, so means that 2s have lower energy. When we have 3p and 3d, so we can see 3p first, so that's why again 3p has lower energy. When I have 4s and 3d, I can see the 4s orbital at the front, so 4s has lower energy. Okay, so I think basically this is the idea for Aufbau principle. Okay, let's continue with tutorial question number 2a. State the Hund's rule. So what is Hund's rule mentioned about? Okay, when electrons are added to the orbital of equivalent energy or degenerate orbital. Okay, so if you still remember, just now we already mentioned degenerate orbital, we consider that they have same energy. Okay. Each orbital are filled singly. Okay, so this singly actually is from the word single. Means that we have to fill the orbital one by one electron of the same spin first before pair up. Okay, so let's look at the diagram at the right hand side here. We have a 2p orbital and then 2p orbitals contain of 3 orbitals. So the first one, electron fill up, followed by second electron in the same orbital. So this one we consider wrong. Okay, because the rules say that we have to fill up one by one. Okay, in each orbital. So now let's look at the second one. Okay, in this case, the electron is filled up one by one. However, we still consider the way that we fill up the electron in the orbital diagram is wrong because they are not with the same spin. Okay. The third pair here, the first electron fill up in the first orbital, second electron also fill at the first orbital. So in this case, we also consider it is wrong. Even though both electrons with the different spin, but they didn't fill up singly. Okay, so we consider this one is wrong as well. So the correct way to fill up the orbital is like this. First electron fill up at the first orbital, first 2p orbital. Second electron also need to fill up into the second orbital, but again, reminder, must with the same spin. Third electron will fill into the third orbital of the 2p with the same spin as well before it is paired. Okay, so make sure we have to fill up all the orbital with one electron with the same spin, then only we start to pair up. So when we pair up with another electron, then it will be with the different spin. So this is the correct way that we fill up the orbitals, we fill up the electron in degenerate orbitals. Let's continue with the next part of the question number 2, which is about Pauli exclusion principle. So what Pauli exclusion principle emphasizes as no two electrons will have same 4 quantum number. Why this can happen? Mainly is because of each orbital maximum only can fill 2 electrons, and both 2 electrons must have opposite spins. This makes the electron cannot have similar 4 quantum number. Okay, now we look at the orbital diagram here. So one orbital maximum only can fix 2 electrons, but here they show us 3 electrons. So let's check out which electron is not valid. Okay, electron C considered not valid. Okay, now we look at electron configuration, quantum number for the electron A, which 1s means n equal to 1, L equal to 0, M equal to 0. And then normally we make it upward is showing positive half, while the electron B will be 1, 0, 0, negative half, because they are in the same building, same floor, and then same orbital, only at the different rate. Okay, means that with different spin. So that's why the S spin quantum number S is equal to negative 1 over 2. Based on the diagram, if you want to write the electron configuration quantum number for the electron C, you will get exactly similar with electron A. Okay, so because based on the Pauli exclusion principle stated that there is no two electron will going to have same 4 quantum number. So this is why electron C is not valid in this case. Okay, after knowing the 3 rules of principle in how the electron fill into the orbital, let's look at what kind of question can be asked. For example, question number 4, we can ask to write down the SPDF notation or draw the orbital diagram. Okay, so first we look at here, oxygen, given the proton number is 8. So among the 3 rules of the principle that we have to follow first, the first one we always follow Aufbau principle. Okay, so according to the Aufbau principle, the electron have to fill up into the orbital based on the energy. We have to fill into the lowest energy first. So among all the orbital, the arrangement of the energy in the order of increasing is 1s, followed by 2s, 2p, 3s, 3p, and then don't forget, before we fill into the 3D orbital, we supposedly have to fill up to the 4s orbital first. Okay, this one just a reminder again. So as I mentioned before that, we have to always remember the arrangement from 1s until 3D, then should be more than enough. Okay, so now second, we are going to fill in the, now we are going to fill in the electron into the orbital. Okay, so oxygen have 8 electrons. So first electron for sure will fill up into the 1s orbital, because among the orbitals that are available now, 1s have the lowest energy. Then second, we are going to fill up the second electron into the 1s orbital also, but then we have to follow with the opposite spin, because so in this case, what is the rules that we follow? In this case, we're going to follow Pauli exclusion principle, because according to Pauli, there is no two electrons with 4 same quantum number. So means that in each orbital, each electron have to fill up with the different spin. Okay, third electron is going to fill up with 2s orbital, because now the lowest energy among the available orbital is 2s. Fourth electron follow Pauli. Fifth electron follow Aufbau. Sixth electron going to fill up into 2p orbital, and then with the same spin. So in this case, actually we are follow the Hund's rule, because according to Hund's, we have to fill up the electron singly with same parallel spin, or just parallel spin before pair up. Okay, so now we already fill up 6 electrons. 7 electron will still in another empty 2p orbital. 8 electron come back to here. So again, we have to follow Pauli exclusion principle. So this is the orbital diagram for oxygen. Okay, so if now I want to write the SPDF notation, so for me, I think it will be very simple. Okay, so just look at 1s orbital has 2 electrons, so I write 1s2. 2s orbital contains 2 electrons, so I write down 2s2. 2p orbital now have 4 electrons, so it's 2p4. So this is the SPDF notation for oxygen. Okay, then next now we are going to look at the oxide ion. So oxide ion with the 2 negative. When the charge here is 2 negative, then we have the idea that the atom going to gain electron. So if we want to gain electron, we have to follow Aufbau rule. Means that we are going to see what is the lowest energy orbital that available in this case. So initially oxygen having 8 electron. So now we want to fill up another 2 electrons. So I have to fill up in 2p orbital, and then another electron also will fill up into the 2p orbital. So for this case, we are going to follow Pauli exclusion principle. Okay, so if I want to write it in the isotopic SPDF notation, so again, 1s orbital have 2 electrons, so 1s2. 2s orbital still have 2 electrons, so 2s2. 2p orbital now have 6 electrons, so I'm going to write down 2p6. So in other words to say, all the superscript number here actually represent number of electrons that occupy in the orbital. Okay, now let's continue with question number 4c. This time we are going to write the electron configuration for magnesium and then magnesium ion. Okay, so in this case, it is a bit different from the previous part. Previous part is the atom going to add electron to form negative ion and ion. This time 2 positive means that the atom is going to remove electron. Okay, so we will look at it detail. So again, I will prefer students to start with drawing the orbital diagram first. Okay, at where we always keep reminding ourselves about the 3 rules that we're going to apply when we fill up the electron into the orbital. Okay, so let's start with the empty orbital diagram. So as we label, this one should be 1s orbital, 2s orbital, followed by 2p, 3s, 3p, 4s, and then 3d orbital. Okay, so now again, we are going to fill up the 12 electron into the orbital. First electron into the 1s orbital, which follow the Aufbau principle. Second electron with different spin follow the Pauli. Third electron follow the Aufbau. Fourth electron we follow the Aufbau and also Pauli. Fifth electron Aufbau Pauli. Aufbau only. Sixth electron we follow Hund's rule. 7 electron we also follow Hund's rule. The 8 electron follow Hund's rule and also Pauli. 9 electron Pauli, 10 electron Pauli. The 11 electron is into the 3s Aufbau, and then 12 electron is in the 3s orbital as well, but with different spin. Okay, so now continue with the SPDF notation. So we will going to give the C answer is 1s2, 2s2, 2p6, and then 3s2. Okay, so now another question for part D is magnesium 2 plus. So just now we already mentioned we are going to remove electron. So if we want to remove electron, remember that we learned in 2.1 ionization energy. When we want to remove the electron, we're going to remove electron from the furthest from the nucleus. So according to this case, 1s until 3s, 3s orbital is the furthest from the nucleus. And then 3s orbital have 2 electrons, so means that we are going to remove these 2 electrons. So after remove these 2 electrons, the electron configuration for Mg2 plus will become 1s2, 2s2, and 2p6. So if you notice, this electron configuration is similar with the electron configuration of O2 negative. Okay, the ion of O2 negative, also 1s2, 2s2, 2p6. Okay, so now here just want to introduce you one term. Because of the electron configuration for these two ions are same, and the number of electrons also same, so we can call these two as isoelectronic species. Okay. Okay, so we are going to continue E and F in the next slide. Okay, question number 4E. This time we are going to write the electron configuration for cobalt and its ion cobalt 2 plus. So similar case as well, we draw out the orbital diagram, and then we're going to label 1s, 2s, 2p, 3s, 3p, 4s, and continue by 3d orbital. Okay, we have 27 proton, means that it will be have 27 electron. So we are going to fill up the 1s orbital, 2s orbital, 2p orbital, followed by 3s orbital, and then 3p orbital. Okay, so when I fill up to here, I will get the idea that we supposedly already have 18 electron, and then followed by 4s 20 electron, 21, the 22nd, 23rd, 24th, 25th, 26th, 27th. Okay, so these are the way we fill up the electron for cobalt. Okay, so if we want to write in isotope SPDF notation, we are going to write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d7. Okay, if you want to simplify it, we also can write it as argon. Okay, argon is the noble gas which contains 18 electrons. So 1s, 2s, 2p already have 8 electrons, and then followed by 3s, 3p, another 8 electrons. So 18 electrons. So means that I can simplify 1s until 3p6 become argon in the bracket, and then followed by 4s2, 3d7. Okay, maybe some of you will ask, Miss, can I use calcium so that I also simplify 4s, and then I just write down calcium and then 3d7. Okay, this is no. Okay, when we simplify this one, we call shorthand. When we use shorthand method, the element that we can use is only using the noble gas. Okay, so calcium is not noble gas, so it cannot exist in the shorthand of electronic configuration. Okay, so now we continue with the second part of the question, which F we are going to write the electronic configuration for cobalt 2 ion. Okay, so in this case again, we are going to remove 2 electrons. So when we want to remove electron, reminder again, we have to remove from furthest from nucleus. Okay, so imagine this is the nucleus in the middle here, and then we have first shell, second shell, third shell, and then fourth shell. Okay, so we have n equal to 1, n equal to 2, n equal to 3, and n equal to 4. So among these 4 shells, which one is the furthest from the nucleus? Is n equal to 4. So means that if we need to remove the electron, we are going to remove the electron from 4s. So 2 plus means going to remove 2 electrons. So we are going to remove 2 electrons from 4s orbital. Then end up the SPDF notation will become argon followed by 3d7. Okay, so again reminder, we always write the electron configuration based on proton number. Okay. And then second, when we want to remove electron or we want to add electron, we have to base on electron configuration of atom. Let's continue with question 4F. Okay, so we know that cobalt ion have 27 electrons, and then 2 plus means that going to remove 2 electrons. So some of the students, they prefer to do like this, 27 minus 2 equal to 25. So yes, cobalt 2 ion consists of 25 electrons, and then before they fill up into the orbital, they will label the orbital first. 3p, after 3p is 4s, and then 3d. Okay, so I repeat for this bottom here, orbital diagram, 3s, 3p, after 3p, reminder again is 4s, and then followed by 3d. Okay, so some of the students will doing like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, okay. Again, reminder, this is the wrong way to write the orbital or electronic configuration, especially for positive ion. Why? Because you didn't remove electron furthest from nucleus. Okay, so if you still remember in the previous slide, I am going to fill like 27 electrons first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 27. So once I want to remove the electron, we are going to remove from the outermost shell, or the one which is the furthest from the nucleus, which is occupied in 4s. So remove 1 electron, remove 2 electrons. Okay, so now based on the SPDF notation, For this one, the SPDF notation is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. This is wrong because does not remove the electron furthest from the nucleus. Wow, this one, 1s2, 2s2, 2p6, 3s2, 3p6, and then we are going to follow by 3d7. This is correct electronic configuration for the cobalt 2 ion. Okay, a very quick summary. When we want to write the electron configuration, first we have to always refer to the proton number, and then we must write the electronic configuration based on the proton number. So if the species is positive ion and we need to remove electron, remember that we are going to remove the electron from the outermost shell. Outermost. So most in bahasa we consider yang paling. Okay, so outer adalah luar. So we are going to remove the electron from the outermost shell. Okay, kenapa from the outermost shell, shell yang paling luar? Because they consist of weakest attractions towards nucleus. So means that it is the easiest for us to remove that electron. However, if we want to gain electron, so we are going to fill up the lowest energy orbital that is available. Okay. So for example, let's say you already fill up to 3p. Okay, 3p already full. Okay, so let's say now you want to fill up the electron some more. So you have let's say you have 3d and also 4s. So which one you are going to fill up the electron? Yes, we are going to fill up into 4s first because we need to follow the Aufbau principle because 4s has lower energy compared to 3d. Question number 5. The table below shows the element J and K with their proton number. So proceed to A1, write the SPDF notation and also the orbital diagram for element J. So we have two requirements for this question. So J contains 15 protons. So if we write SPDF notation, 1s2, 2s2, 2p6, 3s2, and 3p3. Okay. Always remember 1s2 until 2p6 consists of 10 electrons, and then 3s2 until 4s2 basically we have another 10 electrons. Okay, so this is the answer for SPDF notation, 1 mark, and then orbital diagram for the element J. So we can fill up here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 electrons. Okay, so when we fill up with the orbital diagram, we have to very alert with the 3 rules of the principle that apply when we filling electron into the orbital diagram. Okay, so this is the second mark for this question. Followed by question number 2, how many unpaired electrons? Okay, unpaired electron means in the orbital only have single electron. So when we want to answer this kind of question, it will be better we draw the orbital diagram so that we can see it very clearly. So from here we can see the 3p orbital have 3 electrons, which is only have 1 electron in each orbital. Okay, so how many unpaired electrons? So the answer is 3 unpaired electrons. So another 1 mark here. Okay, Continue with part B. Now we need to write the orbital diagram for the valence electrons in element K. Okay, so again, reminder, our valence electron can be considered as the electron in the outermost shell. Okay, so from here we have 34 protons, so means that they also have 34 electrons. So before we can know where is the outermost shell, maybe we need to apply the Aufbau rules. Write down 1s, and then second shell we have 2s and 2p. Third shell we have 3s, 3p, 3d. Fourth cell we have 4s, 4p, 4d, and also 4f. So I think all this is enough to fill up to 34 electrons. So when we want to fill up the electron, first is fill up 1s first. So 1s maximum can fill 2 electrons, followed by 2s. 2s also can fill 2 electrons. 2p, 3s. 2p maximum 6 electrons, followed by 3s. And then after 3s is 3p, 4s. 3p another 6 electron, 4s another 2 electron. If you still remember in the previous slide, we have mentioned that try to remember 1s2 until 2p6 contains 6 at 10 electron, while 3s2 until 4s2 another 10 electron. So minus 20, we still have another 14 electron. So after we fill up the 4s, we are going to fill up the 3d. 3d maximum 10 electron. So minus 10, we still have another 4 electron haven't filled up yet. So after 3d, we are going to fill the 4p. Okay, so 4p now we have to going to fill up with 4p4. Okay, but again, we don't need to draw all because the question is asked us to focus on the valence electron. So based on this SPDF notation, n equal to 1 filled with electron, n equal to 2 also filled with electron, n equal to 3 filled with electron, n equal to 4 also filled with electron. So among all these 4, which is the outermost shell? Yes, very good. It is n equal to 4. So that's why we check out here. We have 4p4 and we also have 4s2. So means that we have to draw the orbital diagram for 4s and also 4p. 4s have 2 electrons filled up with different spin. 4p have 4 electrons, but don't forget we have to follow the Hund's rule when we fill up the electron into orbital. So first electron, second, third with the same or parallel spin before pair up. Then the last electron we will fill up into 4p. So this is the orbital diagram for the valence electron in element K. So another 1 mark. Okay, next, give a set of quantum number for an electron in 4s orbital. So a set of quantum number always consists of 4 numbers which represent n, l, m, and s. Okay, so in the 4s here, we have 2 electrons. So basically, we able to write 2 set quantum number because each electron going to have 1 set of quantum number. So very quickly, we look at when 4s, we know n equal to 4, l equal to 0. So if L equal to 0, M has no others value, will be 0. And then as we have 2 choice, we either put positive half is accepted, or we can give another one is 4, 0, 0, negative half. Okay, reminder, here is given a set. So you only can give 1 set, no need to give both set, but either one can be accepted. So that's why here I've used the symbol or. Okay. Okay, question number 6. Explain the anomalous electronic configuration in chromium and also copper. So anomalous case we consider as abnormal case. Okay, abnormal means that they didn't not follow the rules or the principle. Okay, so we have two examples. One is chromium and then another one is copper. So for your information, chromium have 24 electrons while copper have 29 electrons. Okay, so if you now look at here, this 4s orbital only filled with one electron. So if original with ask us to predict, we may think of 4s has 2 electrons, 4s2, and then we're going to have 3d4. Okay, so when I draw the 3d4, 3d orbital have 5, 3d subshell have 5 orbital. So 3d4 means that 1, 2, 3, 4. This kind of orbital, we will consider it as partially filled orbital. While the one is shown in the answer here, this one is considered as half filled orbital. Okay, so if for the copper, based on if we follow the rules, we will get 4s2 and then at here we will have 3d9. So again, if 3d9, I plot the 3d orbital have 5 orbitals. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this kind of orbital we also consider them as partially filled orbital. While in this case, 3d orbital, this one we consider it as full filled orbital or full filled orbital. Okay, so half filled and full filled orbital have unusual, or we can say that they have extra stability. So this is the reason chromium and copper, they didn't prefer 4s2, 3d4. And also the copper won't exist in 4s2, 3d9 because this condition is less stable. So they will try to make it become half filled orbital and also full filled orbital. Okay, maybe another point that we may remark here. Okay, maybe you'll say, Miss, not 4s orbital has lower energy than 3d. Yes, correct. Okay, before electron is filled, 4s is having lower energy compared to 3d. Okay, but after electron is filled, the energy of 3d will be less than 4s. So after filled with the electron, you can write 3d first and then only you write 3s. It is okay. Or you want to write 4s and then follow by 3d also, no problem. Okay, we are not emphasize which one comes first after you fill up with the electron. Last question of tutorial, question 7. Given the set of quantum number for the highest energy electron in ion Z+. When we look at the set of quantum number 300 positive half, we have the idea that the electron with the highest energy in the ion Z+ is can be found in the 3s orbital. Okay, so let's check the question. Write the electronic configuration for atom Z. Okay, so in this case, means that we will going to think that atom Z supposedly will have extra 1 electron than Z plus. Okay, so the highest energy is 3s. So basically, we will think that we have to add on one more electron into the 3s orbital, like we say have extra 1 electron. So in the 3s, maximum can fill 2 electrons. So that's why the electron configuration will be 1s2, 2s2, 2p6, and 3s2. What is the most stable ion of Z? So now if Z want to become the ion, okay, it will not gain electron, okay, because when we want to get the stable, means that we want to achieve octet stable electron configuration. Okay, so in this case, I think we are going to remove the electron from 3s will be easier rather than you gain electron to achieve octet stable electron arrangement. Okay, so Z tend to lose 2 electron to achieve octet stable electron configuration. Due to Z going to lose 2 electrons, so the symbol of the ion will become Z2 plus. Okay, this is the answer, and then this part is the explanation. So because of in this question, they didn't ask us to do the explanation. So if you didn't give the explanation, then should be no problem. Okay, so we already finished tutorial 2.3. So if we have you have any question, let's discuss more details during the tutorial class. So next video will be related with tutorial chapter 3. Thank you. See you.